Lesson 17.1, Task 1. Solve quadratic equations by graphing quadratic functions. Alright, so we're going to start looking at a new type of function, quadratics. Alright, so a quadratic function can be written in the form f of x equals ax squared plus maybe something else, maybe not, but it has to have the ax squared. The x squared is what makes it quadratic. So just a quick review. We've talked about linear equations. Linear has x to the first power, and that represents a line. You studied that a lot in 8th grade, and we looked at it some earlier last semester. We've looked at exponential functions. Exponential functions are functions where the x is the exponent. Okay, so if the exponent is your variable, then it can be exponential growth or decay, depending on whether it rises quickly or falls quickly. We've looked at systems of equations, which means two or more of any kind of equation, but two or more equations is a system. And we've also looked at scatter plots and looking at the shape to see if you can determine if you can write a function from a scatter plot or not. All right, so quadratics. Another vocabulary term that's very important. So when you hear the name of these functions, it should make you think of what the shape, what type of function you're looking at. All right, so vocabulary is super important in algebra. And the more you are familiar with the vocabulary, the better you're going to understand what we're talking about. So there's a lot of new vocabulary terms in this unit. So make sure that you don't just write these down, but you actually study them and learn them. The same with vocabulary from all the units. The more you understand and know the vocabulary, the easier the questions are to answer because you know what it's asking you to do. All right, so a quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. All right, so this is standard form, and it's important to know that a cannot be 0. If a is 0, this first term disappears and there's no x squared. And remember, I just told you it has to have an x squared. That's what makes it quadratic, okay? All right, so the graph of a quadratic function is called a parabola. The vertex of a parabola or turning point is the highest or lowest point on the parabola. Recall that an X-intercept is the x-coordinate of a point where a graph intersects the x-axis. Also recall that the axis of symmetry or line of symmetry, and that's two terms for the same thing, axis of symmetry or line of symmetry is a line that divides a plane figure or a graph into two congruent means equal, reflected halves. So if you look at this parabola here, here's the vertex. All right, the x-intercepts are the 2 points where it crosses the x-axis, and the axis of symmetry is this imaginary line that goes up through x equals 1 that cuts this parabola into two equal halves. Okay? All right, so it also identifies the vertex here as an ordered pair. Remember, every ordered pair is an x. X comes first, horizontal, and then vertical. So 1, negative 2 is your vertex. Your x-intercepts are where it crosses the x-axis. So here's 0, 0, but they're just identifying the x's. And then 2, 0, which again is just identifying the x's because the x-intercepts are always on the x-axis. All right? And then the axis of symmetry is going to be x equals, and it's going to be whatever goes through the vertex of the parabola. So because this is 1, our axis of symmetry goes through x equals 1. All right, very important to know how to identify those parts of your graph. All right, so it says select the numbers to complete this statement. The function f of x equals 2x squared minus 4x satisfies the definition of a quadratic function because the following is true. F of x equals ax squared plus bx plus c, where a equals what? All right, in this case, a is always your quadratic term. So a is 2. B is with your linear term. My linear term here is -4. And C would be whatever the constant term is. In this case, there is no C, so we're going to say C is 0. All right, so it says using the key features of the graph for f, you will draw and analyze the graph of another quadratic function. G of x equals 3x squared minus 12x. All right, so for this, you're going to use G of x to complete the table. So we've got 3x squared minus 12x. Remember, you've got to do order of operations. So I'm going to get you started, and then I'm going to let you complete the table, and we'll come back and finish it together. All right, so for the first thing here, we're going to take -2, and that's going to substitute in for x. See, this gives you these x values, and all you have to do is plug the x in for x in the function. So it says 3 times x squared minus 12x. So we're going to have 3 times x squared minus 12x. And we're just going to substitute the -2. So 3 times -2 squared minus 12 times x again. So I'll substitute -2 again. Just trying to figure out what this is. Remember, g of x is the same as y. So we've got an x and a y for every function. So this is just in function notation because it's in g of x. All right, so we simplify this. You have to do order of operations. So -2 squared first. Before you multiply, do -2 squared. So 3 times -2 squared is 4. Remember, anything squared becomes positive. And then -12 times -2 is plus 24. So 12 plus 24 is 36. So the number that goes in the first blank is 36. And then you're going to substitute 1. So you're going to do 3 times x squared minus 12x. But this time you're going to substitute -1 minus 12 times -1. So -1 squared, 1. So 3 times 1. -12 times 1 is plus 12. So 3 plus 12 is 15. So hopefully you get the idea. So I want you to take a moment. I want you to go through and complete the table here. And then when you're finished, we will continue. All right, hopefully you completed the table and kind of look and see how this goes from 36 down to -12, and then it goes back up to 36. So you can see that we've got 36 and 15, 36, 15, and we've got 0 and 0, -9 and -9, and then -12 is in the middle. So if you graphed all of these points, you could determine that this right here would be your vertex. That's your turning point. That's went down to so far, and then it started going back up again. Okay? All right, so it says plot and connect the points with a smooth curve to attain a parabola. Which description fits the parabola? All right, so a quick way to do this, since we're kind of on a time limit here, instead of graphing all the points, which you should do at least once just to see what it looks like, but you can also graph the function. Just like we did linear functions, you can type this in. So 3x squared minus 12x. And if I hit graph, oh, my window's really far off from something else. Let's do zoom standard, which takes me back to a 10 by 10 window. All right, and you can see the parabola, how it goes down and it turns and it comes back up. And I already determined that from the table. The bottom of the parabola should be at 2, -12, which makes sense since I put this on a 10 by 10 graph. Since this goes down to -10, you can tell that goes just below that. -12 definitely makes sense for that. All right, so it says plot and connect the points with a smooth curve to obtain a parabola. Which description fits the parabola? The parabola is a U-shaped and opes upwards. That's true. The parabola is U-shaped and opens to the right, opens downward, or to the left. So the parabola definitely opens up. And again, you can tell that by looking at this parabola here. U-shaped graph is a parabola, and that's our function. All right, so it says identify the x-intercepts of the graph of G. Okay, so we can also use the graph to determine the x-intercepts. You can see that it crosses at 0 and 1, 2, 3, 4. So 0 and 4 would be our two x-intercepts. All right, so it says, and you could find that just as well if you had used points and graphed all the points and sketched a curve on a piece of graph paper. All right, so it says complete the statement about the graph of G. The vertex is, all right, so I already determined that from the table. It's going to be 2, negative 12. So 2, negative 12. And then it says draw the axis of symmetry on the graph and then complete the statements. All right, so remember the axis of symmetry is this imaginary line that goes straight down through the vertex. So if it goes through the vertex, it's going to go through x equals 2. So it says the equation of the axis of symmetry is x equals 2 and is a blank. It's a vertical line that passes through the vertex. Remember, it passes through the x of the vertex every time. All right, notice that the rule for G is 3x squared minus 12x. So remember, that was our original function here. Has two terms with a common factor of 3x. You can use the distributive property to rewrite 3x squared minus 12x as 3x times x minus 4. So remember, this is just rewriting using distributive property. We're just using it backwards. Typically, in the last section, we did 3x times x and got 3x squared, and 3x times negative 4 and got negative 12. So we're just using distributive property backwards. And it says because it gives you the function's rule as a product of factors, g of x equals 3x times x minus 4, this is called factored form. How does the factored form make identifying the x-intercepts easier? All right, so if you look at this, the factored form is 3x, and we can set that equal to 0. And then we have x minus 4, and we can set that equal to 0. If we divide by 3, we get x equals 0. And if we add 4, all we're doing is solving for x for both of these. We get x equals 4. So if you remember, the intercepts were 0 and 4. And we determined that by looking at the graph and seeing where it crossed here at 0 and here at 4. So these factors that comes from the equation can be used also to find the zeros or the x-intercepts. We call them zeros sometimes. I don't know if we will in this class, but you definitely will a little later. But right now we're going to call them your x-intercepts. Okay, let's see what their answer is. All right, the x-intercepts can be determined from the factored form by solving the equations. Okay, so they're saying what I did, they just didn't finish it out. All right, how could you use the x-intercepts to find the axis of symmetry? Okay, so the axis of symmetry would be halfway between the two x-intercepts. So select the word to complete the statement. The axis of symmetry is x equals a, where a is a average of the x-intercepts. All right, so a is just going to be whatever the value is that's halfway between, because remember it cuts it in half, and average takes two things, adds it up, and finds the middle. So that is all for task 1. If you have any questions, let me know.